Today we're going to pick up with section 12.2. We're going to start with an example. So it says Susan's sound predicts that students will learn most effectively with a constant background sound as opposed to an unpredictable sound or no sound at all. She randomly divides 24 students into 3 groups of 8. All students study a passage of text for 30 minutes. Those in group 1 study with background sound at a constant volume. Those in group 2 study with noise that changes volume periodically. Those in group 3 study with no sound at all. After studying, all students take a 10-point multiple choice test on the material. These are the students' scores. Again, the value of n is 24. There are 8 in each group. And I'm going to label each of my different types of sound with a variable. So constant sound is group 1, random sound is group 2, and no sound is group 3. I would take a minute at this point and put the data in to your iPad so that we can run the ANOVA. So Susan believes that students with a constant background sound will have a better and more effective studying time than those with either varying sound or no sound at all. So we're going to test her theory by running an ANOVA. We're going to set up our table. In the source column, remember we have groups, error, and then total. We had 3 groups, so degrees of freedom will be I minus 1. So we have 2. For the total, we had a grand total of 24 observations, so that will be n minus 1 for 23, and that leaves error degrees of freedom as 21. From our iPad, we're going to pull the sum of the squares for the groups and the error, and I did calculate the total. Even though mean square is present in your ANOVA test, it can be found by taking the sum of the squares divided by degrees of freedom. We'll run our f-test as a comparison of the mean square from the groups divided by the mean square error. And then we're going to put in this information and find our p-value. And I noticed at this point that I did not set up my null or my alternative hypothesis. So the null hypothesis says that all the means are the same. The alternative hypothesis says at least one mean is different. And the p-value comes up under our alpha value of 0.05. So we do have significant evidence that the means are not all the same. So let me write a conclusion at that point. Now that Susan's test has shown that constant levels of sound is an effective studying technique, we would have set up contrast prior to this. So when Susan designed her study, she already hypothesized that a constant level of sound would be effective. So she would have designed at least one contrast or multiple contrasts to test her theory about the means. So in our first contrast, we're going to label it C sub 1. We're going to compare constant sound to no sound. So what we're saying is psi, we have a coefficient of 1 times the mu 1 or average for group 1 minus 1 times the average for group 3. Now we don't know the values of mu, so we're going to set up a constant to be our unbiased estimator. So a coefficient of 1. 6 is the mean for the group that was having constant levels of sound in the background. Group 2 is not being used at all. That coefficient would be 0, but it won't help me in my calculation, so I've decided to omit that. And then the coefficient of negative 1 times the mean for group 3 that had no sound. So the constant value is 2.625. In order to run our t-test, we will also need the standard error. So the standard error in front here, this number, 2.04561, is the pooled standard deviation. This is found on your iPad. It will be labeled S sub p. And then underneath the square root radical, in the numerator, this is the coefficient for group 1 over the sample size of group 8. I did include group 2. It has a coefficient of 0 and a sample size of 8. And group 3 has a coefficient of negative 1 and a sample size of 8. You can plug all this into your iPad at once, and we get a standard error value for the contrast of 1.02281. So now what I'm going to do is set up my hypothesis to test the difference with these means. So basically, the null hypothesis says that psi is 0. And I'm going to say the alternative hypothesis is psi does not equal 0. If you want to run a one-sided test, you can do so. You could probably say psi is greater than 0. In the t-test, the numerator is the value of the constant, and the denominator is your standard error. So through our division, the value of the t-statistic is 2.56647. And now I'm going to plug this into my iPad. So we're going to run a t-CDF. Our upper bound is our t-statistic. Degrees of freedom is the degrees of freedom for the error. It's 21. And this is the value that I'm obtaining. But actually, p is a 1 minus. And even though we didn't provide a direction in our alternative hypothesis, if I try to multiply this by 2, I'm not going to get a correct answer. So I'm subtracting, and when I multiply by 2, my value of p is 0.017. So at this time, I can say that I do have significant evidence to conclude that my mean for constant sound and my mean for no sound are different. We also were asked to run a confidence interval. So in the front here, 2.625 is the value of my constant for my contrast. For T-star, make sure when you enter this into the iPad, you're using an area of 0.975, and then the last number is the standard error that we just came up with. As I do the math, my confidence interval does show me that 0 is not part of this interval, and that further supports the evidence that I had against the null. Susan also set up a second contrast before running her experiment. She wanted us to compare constant sound to the average of no sound and random sound. So we're going to start the process of the contrast again. So this time they've set up psi. They believe that constant sound has a different mean. They're using a coefficient of 2. And then we're doing the average of no sound and random sound. So each of those means will have a coefficient of -1. Remember, the coefficients must sum to 0. So coefficient of 2, mean of 6 for group 1, coefficient of -1, mean of 4 for group 2, and then coefficient of -1, a mean of 3.375 for group 3. And when we complete that math, our new constant is 6.625. We do need to run standard error again because we've changed our comparison. The pooled standard deviation does not change, but now the coefficient in group 1 is 2. We are using a coefficient in group 2 of -1 and a coefficient in group 3 of -1. And again, they all have a sample size of 8. So my new standard error is a little bit bigger. Again, I'll set up my null and alternative hypothesis. I'm going to use a two-sided test. And then I can move forward with my t-test. So the contrast value over the standard error. Now that t-statistic is getting to be quite large. So at this point in the calculator, we'll run a t-CDF. And it's going to be a 1 minus, and then I'm going to multiply by 2. And that's really tiny. So again, I can show that there's significant evidence against the null, that the means are not all the same, and that the mean for constant sound is different from the average of no sound or random sound. We're also going to run the confidence interval. So again, we should not see 0. So I change the value of the contrast value. The T-star critical value stays the same, but my standard error changes with this problem. And as I move forward with the math, my interval does show that 0 is not part of that range. So again, this is more evidence against the null hypothesis that the means are not all the same. Tonight for homework, you're going to do problem 12.41 and 12.42. There is some data associated with that, and I will send that along. If you have any questions about the notes or any of the problems or homework, please make sure you contact me. Have a great day.